Hello friends, welcome to Joy of Life. So today we are at the ninth episode of System Design Fundamentals, and so far we have talked about a lot of topics like horizontal scaling, vertical scaling, load balancer, API gateway, SQL, NoSQL database and their differences, the CAP theorem. We have covered a lot of topics. We have discussed in pretty much details. We have explored a lot of things over here, and before we begin today's episode, let's go ahead and address the questions before we start the new episode. So here again, I have just two comments, again requesting you all to put a comment. Even if you don't have a doubt, just leave a comment for me so that I understand that you have gone through the video and you have liked it, or you have some questions, or you have some suggestions for me. So please go ahead and drop a note. It means a lot to me. So the first comment is from Shivam Gupta. He says, a great job. So thanks Shivam, I'm glad that you liked it. And comment from John Wick. Thanks for explaining about vnode so thoroughly. Couple of weird questions below, so let's check them out. How many hash functions would or should be present, and how do we determine that? For example, assume there are 4 hash functions h1, h2, h3, h4 and 4 server nodes n1 through n4. Now each node would be hashed to 4 location on our ring through our 4 hash function. How do we determine how many hash functions to have? I believe this would totally be dependent on the size of the hash ring, but want to know your thoughts. Nice question, and let me answer this. This is a little different than what we think. So if you remember, what we have done is we have used the ring, right? So the ring is something like this, and if you are using a vnode, what will happen is your nodes will sit over here like n1, n2, n3, n4, and let's say I have 4 nodes, right? So what will happen is it will again start repeating from n1, n2, n3, n4 like this. Another way that you can do this replication is, let's say I have 4 server, so my n is 4, so you can replicate it to n-1 server all the time. So you can replicate to 3 server all the time. So let's say if the data goes over here, then what we can do is we can put in the next few servers to store the data as a replicated data. These are replicated data. Here what we can do is we can avoid the use of using multiple hash functions, because it will be a limitation, right? If we have x hash function, that means only x minus 1 replica can be stored, not more than that, right? So in a better way, if we let's say have 100 servers, so n 0 to 99 we have, right? And I wanted to store the replication in say 30. So what I can do is, let's say my data is going on 28 server, so we can put it in 29, 30 and so on the next 30 nodes. We can do that. We can do the replication if we are using the vnode strategy. So this makes things very simple, and you don't have to rely on too many hash functions. Coming to the second question, assume a node goes down. So this node contains the data for multiple ranges. Where would this be stored? Hash map. It depends. This is just a concept. So you found the ring. Now it depends upon who is using the consistent hashing of the vnodes, right? It can be a cache, it could be a database. So where you are going to store in a hash map or a tree map or in some file, it totally depends upon the implementation. So there is nothing fixed. Would it make sense to have a central authority like Zookeeper for Kafka, which coordinates all the node, which maintains the information and rebalance accordingly? Yeah, we can use Zookeeper, a configuration management service. We can make use of that. But in a system like Cassandra, what happens is we do not have master and slave. So everybody independent, and they are called as peers, right? So each of the peer hold the information. So you don't need a configuration management service. It can exist without the same as well. So what happened? They are all peers, right? So let's say we already have 10 peers, right? And now the 11th one, as it comes, these can talk, right? So they uses a gossip protocol. So they will pass on the data to this guy, the new guy over here, this guy, and he will get the data from its peer. So it makes sense to have a configuration management system. You can use it with the system like Cassandra or wherever you are using consistent hashing. But in system like Cassandra, you can say that they are pretty much independent from it. So John, I hope I was able to answer your question to some extent. Do let me know. And yeah, let's continue with today's topic. So today we are going to talk about a very interesting thing and most frequently used thing, that is caching. So cache is something that is used everywhere in your PC, in your CPU, in your browser. Take any application that you use, you will find that cache is present over there. So from a very high level, our application looks something like this. You access the application using your mobile or laptop, the request goes to the server and the request is processed and the response is sent back. And that's how you get to communicate with the server. So let's go a little deeper into this. So what is the processing that I talked about? Processing could be of three nature. First is I go to the database, I get the data, I send the data back to the user. Second is we use some algorithm to generate some of the data based on the inputs given by the user or from the database record. And third is we talk to another service in order to get the data. This other service that we talked about could be an external service as well and could be an internal service as well. So let me give you an example. Let's say this application, this server over here is Uber, right? And this one we are talking to Google Maps in order to get the location from the Google Map server. So we are using Google Map in order to get the location coordinates, and we are using the algorithm to perform some operation, find out the shortest route and everything, and we are using the DB in order to fetch some records of the user. These things over here comes with a limitation as well. For example, so if we have a complicated algorithm, so we need to have the processing power in the CPU, right? We cannot store or we cannot process a lot of requests at the same time. So we have to have multiple CPUs in order to get that done. So each one of this external service will take some time, right? Because you are sending a request to him, he is sending you a response and you are processing the response and then sending the actual response back to the user. If you are using some complicated algorithm, it will take some processing power as well. You cannot process too many requests in a single machine. You have to have more computation power. If you are using a DB, you have to execute complex query in order to fetch the data, right? Maybe you're passing the user ID and you need to fetch the user profile based on that, or some complicated query, right? Now your database is not in the same server as the main server, right? It is in some other server. So what we can do is, suppose you are fetching my profile. So once you fetch my profile and before you send it back to the user, you are going to store the data into a cache. So you can introduce a cache over here. So instead of hitting the database, what you can do is you can first check your cache if your data is present in the cache. If not, you can send your query to the database. Similarly, when you are executing some algorithm, in that case also what you can do is you can compute, you can process for a particular user and you can send back the response after storing it into the cache, right? So that if the request for the same user comes again, you don't need to perform this processing. You can simply serve the request from the cache. So it will start looking something like this. We are not going to compute this data every time when we get the same request. Similarly, a location might be requested multiple times and we don't need to fetch the information from Google Maps server every time. What we can do instead is we can store the response into the cache, and next time when you are requesting me for the data, I first check in the cache. If I don't find the data in the cache, then I go to the Google server. So the flow can look something like this. So one big benefit of doing this is to save your time. So I can send you the response faster. Maybe querying into the DB takes some 20 milliseconds of time. Okay. So let's say this cost me around 20 millisecond of time. This operation cost me 2 millisecond of time. So first time it will take 22 milliseconds because it will go and check in the cache. It will not find the data. It will go to the database. So it will take 22 millisecond time. But from the subsequent request, it is going to take only 2 milliseconds of your time. So you can respond it faster, right? Similarly, for this algorithm, maybe it takes about 35 milliseconds. You are doing some complicated processing over here. but again this takes 2 milliseconds, so you save time in all of this. So let's say when you are hitting an external service, it will cost you even more, let's say 200 milliseconds, and you are saving all this time. And also, if you know that when you are using an external service, so there is something called a throttling. So when I bought this service from Google to use their Google Maps service, they have said that your request will be throttled after 200k requests per minute, let's say. So if I am making more requests, let's say Uber is very popular app, right? So there are so many trips that's booked. And let's say many user goes to a particular location in the city center. So we don't need to go to the Google Maps in order to find the details of that particular region or location. So let's say 5,000 requests came for the same location, but I will reach out to the Google Maps server just once in order to get the data. So this is going to help me not only to make less number of calls, not only to give faster response, but also, just for example, let's say this server over here is down for 1 minute. It was not sending any response back, right? But I can still serve the data that is there in the cache, right? So I have a lot of data that is already stored in the cache, and I can still cater to some of the request, right? Similarly for the database server might be down for a while, but I don't need to fail the request for all the user. For few user, I already have the data cached and I can still continue to serve them from the cache, right? We are still looking from a very high level and slowly we are coming down, right? So let's break it down even more. So I have this server over here and I have my client. So this is processing my requests, but there are some static and large media file that is also loaded. So let's say if I open amazon.in, so you see there are a lot of images and everything that's loaded up over here, and I have to load them very fast. So these days what we look for is speed. So all the static media content and everything, we store them in the CDN. So all the static media request will go to the CDN in order to get the data. So if the data is not found over here, the request will come over here. So CDN is nothing but it is also a type of cache which is known as content delivery network, which sits between your origin server, which is this one, and your client. So these are your clients. So CDN are used mostly for the static files like HTML, CSS, JavaScript, image, videos, all those things will be served from your CDN. So from a very high level, the system looks something like this. Even on your client side, they will have a cache inside them as well. So if it is your mobile, it will have a cache of its own inside it. So your phone will have its own local cache, and even your PC and whatever device you have, they will have their own cache as well. Even Google Maps will have their own cache. Let's not go into that. So let's understand this from our server's perspective, that is the Uber server's perspective. So what can we cache in this case over here? As we saw, we can cache the entire database query. That means the record set that we are receiving, we can cache that. We can cache the objects of the algorithm as a result. We can store the response received from the other server as well in the cache. So there is no limitation. You can store whatever kind of data you are looking for. We are not going to go into Redis or Memcache or any particular implementation in this video, but we are going to understand from a high level. So as we saw that our clients has a cache inside them, similarly, our database also has a cache inside them. So as I mentioned earlier or at the starting of the video, that literally we have caching everywhere. So let me make this bigger so that I can fit the cache inside. So inside database, we have the database caching as well, so that the database can optimize the queries and send the faster response back. So these can be configured via your database configuration. So while setting up your database, you can configure these things and you can tweak or change the configuration based upon your need. Also, what we can do for some of the requests, we can have a cache at this level. So even before the request hit the server, we can send the response back. And this type of caching is known as web server caching. So the request that was coming previously directly over here, let me remove this line. So instead it will come to the cache over here, and from the cache, if required, the request would be redirected to the server. So we have a web server cache over here as well. So from a very high level, we have the client caches present on the clients. Then we have the CDN. Then we have the web server cache. We have the database cache, and we have the application cache as well. So what kind of data should we cache? So the most frequently used data is cached. As you understand that we have throttlings, we have computation, we have all these things which can slow down our server, right? So the main objective of the cache is to keep the server light. So if we have to perform this processing of the algorithm, it will cost me 35 milliseconds. And if we can serve the data from the cache, it will only take 2 milliseconds. So you can understand that it is considerably lower in time, right? Similarly, if we are getting the request from the external server or any other service, it's going to cost us time, right? We want to cut off those things, and we are doing that using the cache. So cache is a little different from your database. It is not a persistent memory. You can take a snapshot and store, but definitely it is not a source of truth. The source of truth is the Google Maps server, the algorithm, or the database. It could not be the cache, because cache might have stale values. We are going to understand this in a lot more details down the line. So now let's understand what are the ways of writing the data into the cache. The first way of writing the data into the cache is called a write-through cache. So in this process of writing through the cache, the data is written into the cache, so the data goes over here and it also writes into the database. So the cache data, of course, is available for a fast retrieval, and since the same data gets written in the permanent storage, we'll have complete data consistency between the cache layer and the storage layer. So this is my cache layer, this is my storage layer. So we are going to have a consistency in this approach. Also in this process, it ensures that nothing will get lost if the cache crashes. So if this cache crashes, it is not available, it is gone due to some reason like power failure or whatever system disruption, we will still get the same data, but it might cost us a little more time, but we will get the same data back because we are writing it through the cache. Another strategy we have is called write around the cache. So this technique is more or less similar like the write through cache, but the data is written directly in the permanent storage, that is in your database, bypassing the cache. So it will be stored directly over here. This can reduce the cache being flooded with write operation. So how it helps is basically maybe the data is written, but the data will not come into the cache unless we receive a read request for that data. So it will bypass the cache while writing. So it will go around the cache and write it over here directly. So it might happen that not all the writes are a candidate for reading it back, or they are not frequently used. So in that case, write around cache will help you not to flood your cache with the data that's not being used. So that's the difference between write through cache and the write around cache. So write through is something like this and write around is something like this. It will happen directly. And there is another technique called write back cache. So the data is written into the cache only, and the completion is immediately confirmed to the client. So as soon as we finish writing on the cache, we are going to say, okay, we are done with the task. The write to the permanent storage is done after specified interval or in batches. So what will happen is that maybe after every 10 seconds, I am going to flush everything from the cache to the DB. So this results in low latency, definitely, because you are just writing to the cache and saying that, okay, I'm done, right? So of course your latency is going to come down the approach like this, and you are going to have a high throughput for write intensive applications. So you can say that, okay, I've written to the cache, I'm done. However, this speed comes with the risk of data loss, right? Because this cache, if it goes down without flushing the data into the DB, you lose all the changes until the save point. So you are going to lose everything that you have done, and you are going to lose some portion of your data. So that is the trade-off with all these three approaches. Now coming to the eviction part. So we are storing the data into the cache and this data need to be evicted, right? We don't have an infinite storage into the cache. The cache memories are pretty costly and that's why we don't store everything on the cache. So we store only the data that is frequently used and we have to evict some of the data that is not frequently used, or we have to find some other ways of doing that, right? So we have to evict the data from the cache. So one way could be your first in first out. So the cache evicts the first block that is accessed first without the regard of how often or how many time it has been accessed before. So you take the first one that is accessed first and you evict that out. Similarly, you have the LIFO, last in first out. So the cache evicts a block accessed most recently. So you can configure all these strategies. You can say that I'll evict the data that I have accessed last or I have accessed first. But these are not used that frequently compared to the least recently used or LRU. So discard the least recently used item first. The one that is least recently used will be evicted first. That means the request on that particular item is not that high compared to the other item that is stored in the cache. So you will find LRU to be the most commonly used cache eviction policy, and it is by default in many of the caching solution as well. Then you have MRU as well, most recently used. So discard, in contrast to LU, it is just the reverse of LRU. The most recently used item will be discarded. So these all techniques might depend and vary from scenario to scenario. Then you have the LFU, or the least frequently used. So the count will be taken into consideration before evicting the data. The object or the data that is used least often are discarded first. Then you have the random replacement, wherein some randomly selected item is just moved. So these are several eviction policies. You need to understand which one is best suited for your use case. So this is the list of your eviction policies over here. And these are your cache access pattern that we have talked about: right through, right around, and right back. Also, when storing a data in your cache, you can have a TTL. So TTL is nothing but a time to leave for the entry that you are keeping. So the basic format how we store the data in a cache is using a key, and each of the key is associated with a value. So the value is the object that we are willing to store, and the key is the lookup value. In this episode, we are going to keep it at a very high level. So we have seen different type of caches. So let me list them down for you. So these are the type of caches that we have talked about: client side caching, then we have the CDN, we have the web server, your application server caching, we have the database server. There is also another type of cache, that is your DNS side caching. So when you type a domain name and you get the IP address for the same, so that resolution also happen using a cache. So your DNS server also maintains a cache from where it serves the response. So far we have seen these benefits using a cache. So decrease network cost. So again, you don't have to make additional network cost for the same request. You can serve it directly from the cache. You don't have to go to the Google Maps server in order to get the data. Second is improved responsiveness. So definitely, as you are responding very fast, you are saving all this big time like 200 millisecond, 35 millisecond, 20 milliseconds. So you are directly serving from your cache. So your application is much more responsive. And another benefit that we have seen is increase of the performance using the same hardware. So since we are not using the computation power over here, we are relying on the cache in order to send the data back. We are saving on the CPU processing as well. We can serve more requests in the same time, so we can have increased performance using the same hardware that we have. And also we have seen that if our external services are down, like our DB is down or our Google Maps server is down, we are not completely down. We can still serve the data that we have in the cache. That's a big way in which we can improve our application, because the most frequently used data is already with us and we can still cater those requests, right? And to add to the third point, that we run a complex queries in the DBs, right? So we can save time there as well, right? We don't need to hit the same queries again and again. So we are saving on the performance in the hardware, both in our server, in the database server, as well as in the Google Maps server, wherein we have some throttling or we have some limit on the number of requests that we can make. So in general, cache is used mostly everywhere. You can take for data lookup, you can store it in the application side for your RDBMS, you can have your session stored in your cache, you can have your token cached, you can have your in the gaming and as well as in the web pages, it's heavily used. So almost everywhere we use the cache, but there are several advantages and disadvantages using the cache. We are going to dig them in the next episode where we are going to understand each one of the strategies. We have just talked about the benefits yet, but there are certain disadvantages in each of the strategies that we talked about. We have already talked about a lot of strategies, but we are going to understand them in a lot more details in the next episode. What are the different strategies of read through or lazy loading? What are the advantages, disadvantages of the write through? So we are going to go through each one of the strategies or the access pattern that we have talked about in the next episode in lot more details. We'll cover the eviction policy and the access pattern in the next episode, wherein we will just focus on those two areas, and on the subsequent episode we are going to install a Docker container of Redis, and we are going to play around and see how we can store things and what it offers. So in this episode, I am going to keep it till here. We are going to break it down in the next episode. This is still at a very high level. And yeah, that's all from this episode. Do let me know in case if you have any questions. And do let me know in the comment section. So yeah, that's all. Bye bye and take care.